Hello everyone, welcome back to the new video. So in this video we will set up our local database to our app. But before that let's have a brief intro on the Room library. Room is a library in Android that helps store data locally on the user's device. It is built on top of SQLite, a powerful local database system. But Room makes it much easier to use by allowing developers to work with Kotlin classes instead of raw SQL queries. For example, if your app needs to save users' data like nodes, tasks, or blogs post, Room stores this data in an SQLite database on the device, making it accessible even without an internet connection. Room consists of three main components: entity, DAO, data access object, and database class. Entity represents a table in the database where each column is defined as a property in a Kotlin class. DAO defines methods for inserting, updating, deleting, or retrieving data, eliminating the need for manual SQL queries. Database class acts as the main entry point, specifying the entities in the database and providing access to DAOs. With Room, managing local data becomes simpler, safer, and more efficient, ensuring a seamless experience for both developers and users. Now go to our Android Studio and set up the Room database. And that Room database code goes into this data package. So here in this package, create one more package with the name local. And this local package will keep all the codes related to local database. And here first thing, let's create one more package. And here we will keep all our entities. Entities are simply just tables in the database. And first we will keep an entity for blog, and let's name it blog entity. Use the data class and let's define all the fields we have for our blog. Now this will be our entity class. So how we will tell Room that this is an entity class? We just need to specify this data class with this entity annotation. And this annotation is coming from that Room library. Now Room know that how it needs to create the table. Let's also define this ID as the primary key. So based on this ID, it will distinguish between different blocks. And if you open the documentation of this primary key, you will see the auto-generated value is by default false. It means it will not generate this ID automatically. And we are going to use the same ID we have specified in the JSON file. Now next thing we need to define our DAO, blog DAO, and this will be an interface. Why this is interface? Because here we just need to define few things with the annotations and the implementation will be done by the Room library. So first thing we need to tell the Room library that this interface will be our DAO. So for that we need to specify this interface with this annotation. So we will be having four functions. First function let's define with the name get all blogs, and this function will give us the list of blog entity, and we need to tell the Room library how it needs to use this function, and we need to use this query annotation. And here we will say that whenever we will call this function you need to select everything from blogs table. So here we are accessing this blog entity. This is because we have not specified the name of this table. So in this entity annotation, we have one parameter with the name table name, and let's use blogs. And rather than providing like this, let's go to our constant object and here create one more constant and use this constant to our entity. Now in our DAO, here we will say you need to select everything from our blocks table. Next function, let's define for inserting all the blocks. So here just use this insert all blocks, and we are going to provide the blocks as the list of block entity. And how we are going to tell what to do with this function to the room library? We have a special annotation with the name insert. So whenever we will call this function, room will insert whatever we are providing into this table. And let's also specify one more thing, this on conflict strategy. So here some blocks are already available with the same ID. So what it needs to do? It needs to use this on conflict strategy dot, and we have many. So let's just simply use replace. So whatever will be the existing blocks with the same ID, it will replace those with the new ones. And next function, let's provide the get block by ID. And we are going to provide the block ID as the integer type. And this function will return us the block entity, and this can be nullable. And we are going to tell about this function with the help of this query annotation. So room needs to select everything from blocks table where ID field is equal to the block ID we are providing. And this is how we write the queries. It's quite simple. And the last function, we will be having this clear all blocks. So we need to call this function whenever we need to clear all the blocks. And let's rename this function to simply delete all blocks. We need to provide the query with delete from blocks. So it will delete everything from the blocks table. And this is how we define the various operation functions on our local database in this DAO. And we use this interface. We just need to provide these functions with the annotations, and all the hard work of implementing these functions will be done by the Roam library under the hood. Next thing, we need to define our database class. So here let's use one class with the name block database, and this class needs to be an abstract class, and we need to extend it to the room database. So this class will get all the functionality of room database. And we need to annotate this class with the database annotation. And here we need to define all the things we have right now in the room database. First thing, these entities. So right now we just have one entity with the name block entity. And next thing, we need to provide the version we have first. And in future, if we change anything in this schema of local database, then we need to update this version. And next, let's provide this export schema to false. And here it will not export the database schema into any folder. And we are going to get to our block DAO through this database class. Now next thing, we are going to use this local database to our block repository implementation. Next thing, we will get the DAO. So let's name it local block data source, and this will be our block DAO. So again, we are providing the object of this block DAO outside this repository implementation class. So again, we need to tell the Coin how it needs to create this block DAO. So for that, go to our DI and Coin main module. So here we need to define. But one more thing, we need to understand that we will get this block DAO through the block database class here. So first thing, we need to create the object of this room database. So for that, again, let's create one object with the name database factory. And again, we will use one function with the name create. And we will provide the context to this function. and this function will give us the blog database object. And how we create the room database object? We need to use our room, and we have one builder, database builder, and we need to provide the context, and the context we are going to get through our context. And next thing, this class. So here we need to define what class object we need, and we have this blog database class. We need the object. And next we need to define the name of our database. And again, let's use our constant file. So this will be the name of our database, and use this constant here, and use just this build function. And this is how it will create the object of our room database. And one more function, let's use this fallback to destructive migration. So what this function do? Whenever we change anything to our local database schema, then it will drop all the previous data and it will only save the new data. And let's use this to provide the object to our Koin library. So here we need to tell the Koin that first you need to create the object of our database with the help of this database factory, and we have this create function, and we are going to use this get function for the context. And with this get function, it will get the context from its own code base. And context we already have specified to this Coin library how it needs to get. Go to your main application class, and here we have specified how it needs to get the context, and we don't need to worry about it. Next thing, we need to provide the object of that DAO to our repository. So the object of DAO will be created. First, let's use this get function, and it will get the blog database object, and there we have the blog DAO. And if you press Ctrl B, and here we have the blog DAO object. And this is how our blog repository implementation will get the object of this blog DAO. Now one more thing let's do is, let's keep this constant in a separate package with the name util, and put this inside util and close everything. Hey everyone, if you are finding this tutorial helpful, you will love my premium Udemy course where we will build Measuremate, a fitness app using Jetpack Compose. We go in depth on the Firebase authentication, Firestore, and more. Check out the course in the description and take your skills to the next level. See you there. So now we need to update this function. First thing, we will get all the blocks from our remote database and use this val remote blocks. And here let's use our return function with if condition. If our remote blocks are not null, then we need to use this code. In the else branch, we need to use this code. So here, if our remote blocks are not null, then first thing we are going to use this local block data source and delete all the existing blocks. And next thing, we will use this local data source, and we will insert all blocks we have from the remote. So in this way, we will update the latest blocks to our local database. Now we can return these blocks to our function. And in the else block, it means if our remote blocks are null, either we got some error or we don't have any internet connection. So in that case, we will get the local blocks from our local data source. And here again, we are going to check with the if condition if our local blocks is not empty. It means we have some blocks, then we are going to use these blocks, and in the else branch we are going to provide the null value. Now the error we are getting because these functions need the block, but here we have the block entity because we are saving these blocks to our local database with the help of this block entity. So we just need to create one more mapper function that will map those block entity. So go to our mapper package and create one more file with the name block entity mapper. And here we will be having one function on this block entity with the name toBlock, and this function will just convert those block entity to our block data class. And here we just need to map each values to their respective values. And to this block, one more field we need to provide is the contact. So here we can simply use null, but let's provide that thing through the parameter of this function. So it will be more flexible. So let's use this content and provide the string, nullable string with null as the default value, and use this content. And let's also create one more mapper function on the list of block entity. So this function will map the whole list. Here just use the map and it will map each data class to this toBlock function. And go back to our repository implementation, and here we need to convert these local blocks to our blocks list. And here again we need to create one more mapper function that will convert this block TTO into this block entity. So go to our block TTO mapper and just use this code and paste it here. So this next function will convert the block TTO to block entity and use the block entity here. And in block entity we don't have any content. And again this function will convert the block DTOs list to the block entity list. Just use the toBlock entity. And let's use this function to our repository here. So this will be the implementation of our function. Here first we are getting the blocks from our network, and if we get the blocks, then first we will save those blocks into a local database, and then we will use those blocks to our screen. And if we got some error, in that case we are going to get those blocks from the local database. And if in any case we don't have the blocks in the local database, then we are going to show the error. And we can see, because of using the clean architecture, here in our view model we don't have to change anything. Here view model doesn't care about how you are getting those blocks. Its only job is to manage the user section and state. Now let's run our app and see how things are working. So here we have our app. Now let's see the local database. Go to this more tool window and open the app inspection. And here we have our block database. And here we can see we have a block table, and we can see this is how the data will be saved on the local database. So if I now close the app, and let's also turn off the internet and open the app again, and we can see without any internet connection we have our app with the blocks data. And this is how the local database will be helpful in our use case. And that's all for this video. We have successfully learned about how we can set up the local database with the help of Room Library. In the next video, we will talk about how we can handle the errors more efficiently. Right now, we are simply using the null value as the error case. As always, if you have any questions or suggestions, feel free to drop them down in the comment section. And if you are finding these videos helpful, please like the video and subscribe to the channel. Thanks for watching.